My name is Mike Müller, and I will be your tutorial instructor for the next 90 minutes. I would like to introduce myself in a few seconds. So I've been a dedicated Python user since 1999, so I can always claim since the last millennium, starting with version 1.52. We just discussed this here. So I do have a scientific background. We worked at a research institute, and then in 2004 I gave my first training, and though the things developed. And since 2010, I spent most of my time on Python training. So I do quite a bit of these kind of things that I'm doing here. Good. Today we want to talk about aspect on the programming. I just would like to know a little bit about you very quickly. Who uses Python less than 1 year? Please raise your hand. 1%, good. Between 1 and 3 years? A few people. Between 3 and 5? Okay, most. More than 5? Yeah, so kind of equal, more or less equal distribution. So the time of using Python is not the best measure to how good you are in Python, what you know, but you're here to learn something, you know, about some features of Python. So please download the material. I upload the QR code was wrong. My tool to create QR codes was in there, so I somehow copied the name twice. So, but now this is a code. It's a PDF and the source code. So please use this bit.ly link there. I checked that it should work. Aspect on the programming, give you a little bit time, and then I would go quickly to the material you want to cover, since we have only one session, which is not much. So, and I'm going to use a JupyterLab notebook. You don't have to. You can use whatever tool you like. You are encouraged to work along if you like to. If you don't like to, just want to watch, is also fine. I try not to be too fast, even though we don't have much time, so I have to speed up things first. So I will, everybody has the link? So quickly go through. This is the material. So if you download, you will have this PDF with the material. And this is the content. So I make it a bit bigger here. So we're going to have, there's two big sections, basic decorators, where I explain the basics, so you get to know how to write your own decorators. And then we go in a few more advanced topics like parameterization and using classes, writing decorators, and all kind of things you can do with decorators. Yeah. So I do have examples for all of them. And also we do have exercises, but due to the kind of short time, we cannot do the exercises. It doesn't work. So you have to get the exercise as a homework. I do have a solution PDF, so I will add the solution PDF after the training to the same link, to the same zip file. And if you download it again, then you will have the solutions, which are example solutions. Yeah, so it's quite a bit of topic. That's why we have to skip the exercises doing yourself. So I do start with this with a notebook. I always make a notebook, and the first one is the basics. Basic decorators, and we look at what decorators are, what they're good for. So who of you use decorators? You put this @ sign in your code and it does something. Who of you used it? Most of the people. Who wrote or tried to write our own decorator? Oh, quite a few people. So first, I want to give you some incentive why we do need decorators. So I mentioned I started with Python 1.5, and I think in 1.5 you could do very similar things than you can do with decorators, which are a bit newer. So motivation, the motivation for decorators. So if you have a class, lowercase class. So, by the way, is this big enough a font for the back of the room? Yeah, okay, cool. So if you have a class, and I define the class, then I can have something like a static method. So in Python, static methods are not really necessary if you don't want to. So I think you could delete static method from language, this still would work. In language like Java, you need them to write functions. So a static method is just a function that resides inside the class. This wouldn't work because I forgot the self, but I don't want the self. And to do this, I can do something like this. I can say a static method and turn this function into a static method, which does nothing. It circumvents the binding. So usually when you have a method in the class, then you can call it through an instance and you don't use the self, but you have to put the self in here. So this class, and I can use this function on the class, and it behaves like this, and I can do the same thing for the instance I have to make first. So I have to make an instance first, not using the instance. So I make an instance of my class, and this works. So this does the same. If I don't have the static method, if I have a method, and the method I would write a self in here, and then I do the same thing, I return.
Sorry. So, sorry for interruption, but the remote attendees would like you to show the QR code longer so they can also download the material and stuff.
Yeah, so this would be the link. Decorators, QR code.
And the download link.
The QR code is broken? That's a new QR code. That's a new one. Please scan and try, but it should be new. Because I saw the mistake when I made. Yeah, that's a new one. So I deleted the old one. Decorators are a great means of injecting, so the motivation before they go to the basics, are great means to inject code. That's why it's called aspect-oriented. You have an aspect, some kind of what's called cross-cutting concern. And we come to some examples like logging or caching. And decorators are great means to inject this code into your program. Yeah? And this is typically called aspect-oriented programming, to give it a fancy name. We can also say decorators are functions that take functions, return functions. So that doesn't sound much better, but that's essentially what happens. Good, so everybody has a link. So continue. So now we have this this class. So to see the normal is, so now if I go to the, and I have my instance, maybe that's not good flow. If I have this normal instance on my C, I can call my method, yeah? And when I have to redefine everything. So if I call my method, this works. If I do the same thing on the class, it doesn't work because it's bound. And if I call it like this, I get an error message, and I have to supply the first argument. That's object-oriented programming. You need the self argument. You have to write the self. So sometimes you want to have a static method, which is just a function that's located inside the class. It's located inside the class. And just a normal function, but for organizational reasons, you want to have it in the class. So you see, it's very important that you know that's a static method because the thing behaves differently. So I didn't forget the self. I don't want to write the self, but this only becomes clear if I see this line. The problem is I can only write this line after the fact. I have to define the function first before I can write this line. Yeah, and that's a kind of a problem. Here it's kind of okay because the function is very short. If this function has 10, 20 lines, you might not see this line there and just wondering what it is. Yeah, this can be problematic. So, and now there's something new. Instead of this, we use a decorator, so I call this class C2. And now I do the same thing, I achieve the same thing by adding a decorator here, and I use static method in front, which does exactly the same. So this would be equivalent to this line. So if I can delete this line, and now if I do this, this would behave exactly the same. And if I make a new instance of my class, then my function would run on the class without a problem. Yeah, so that's the whole thing. That's what it's doing. So this static method decorator is just doing this line for you. The very important thing is that you do it in front. You can see it, and it's also a nice colorful magenta color here. And you see something is happening, something's different. And this is the important thing. This is, some people call it syntactic sugar, but it's important syntactic sugar because this is a very important message that we convey with these things. Good. Same thing applies to class methods. I want to skip this here. This is exactly the same. Class methods are very often used in Python to have a kind of what's called a second constructor, if you want to call it. So class methods would be another application where we typically use decorators. Where you can find decorators in the wild, there are a lot of libraries that use decorators, sometimes extensively. Click is one, the command line tool program, which is pretty common. Click. Django is using decorators a lot, like for who is allowed, permissions, and so on. Flask is using decorators. Science is using decorators for types. Number, if anybody is in numerical programming. There's a lot of libraries that use decorators, and they are all for the same purpose, to modify functions in one way or the other. Okay, this is a motivation. And the important thing is that you think this one is just exactly the same as this line. And when you know this, you can explain a lot of things what actually happens with decorators. Otherwise, it's too much magic. But in the end, it's just this thing that's going to happen. And if you do this, you can explain to yourself what happens. I would like to introduce another concept, the concept of a closure. Who knows what a closure is? Yeah, a few people. So closure is a term from functional programming, and since we have a function, it takes a function, returns a function. This is some kind of stuff from functional programming. So Python is a multi-paradigm programming language, and it supports a few functional features. It's not a real pure functional language, but it has a functional features. And I give you an example. I have this outer function. Inside the function, I can define a new function. So I can define a new function which I call inner, which takes an argument 2, and now I can say return argument 1 plus argument 2. And now I do this a different thing. I say return this inner function, so I generate a new function, and now I can say inner 10 is outer 5, in 5 or 10, if I say 10. Now I can have this thing, which is a function, and I can call it with 4, and you see you get a 14. So this is actually calling the thing. So I generate a new function. If you look at the function, you see this function. This is a function with a strange name, And the outer function does nothing else than give me back an inner function. And of course, I supply the 4 here, but somehow it remembers a 10. Yeah, usually when you have a function, you get something in. When the function is gone, everything is gone. All those variables inside the function are not available anymore. Yeah, there's scoping. There's a local scope of the function. When you call it, they are available. If the function is called, they are gone. But somehow, this inner function has access to this arg1 from the outer function. And how does it work? How does it work? So, and this works with this closure. So you can say closure, and you see, if you look at the closure, this is a tuple, which you can see by this trailing comma here. One tuple has a comma there. You can access the first element, and then you can look at the cell content, and there you have your 10. So this is a very common concept in functional programming, and Python uses this also. So this outer function holds on these arguments because inner function needs it. So the minute you define it, it realizes, okay, this arg1 from outside is used in here. And this concept is used now for our purposes, writing a decorator. So now we know what decorators are good for. Now we know a little bit about closures, how closures work. And now we're going to write our own simple decorator. So I start with a decorator that doesn't really work, but it gives you, sometimes it makes sense to do something that doesn't work and start to improve. To make it work. So I write a function hello that takes a function and prints hello. So this is just a function, and now I can use my decorator, hello, and I can define another function. So we will use always a very simple function, add a and b. So we will define this function a lot today, and I return a plus b. So and if you see this, now something strange happens. Something strange happens when I apply this function. You see the hello, and I define this function. Now something happens when I define the function. Why is this? So the explanation is as follows, because this is just doing the following. So this is always the explanation. You say add equals hello add. So that's what this decorator is doing, and now it becomes very clear that you just print add. That works. That works. The decorator does no error message. It works. But when I want to call my function, which should give me a 7, I get this the most common error messages on Stack Overflow, non-type object doesn't do this and this. And now you have this problem. Yeah, the non-type is not callable because I forgot something very important. I replaced my function with what? With a return value of hello. And what's the return value of hello? It's none. If you don't put a return, Python automatically returns none. So now I replaced my function with none. This is probably not what you want. That's, I think, in all cases, a mistake, I'm pretty sure. You can do it, but it doesn't make a lot of sense. So we have to write a better decorator, and to do this, we have to do something. So you see, also this happens at definition time. This could be use case for decorators to do something at a definition time. The more common cases do something at runtime. So you replace your function, that your function is doing something different at a runtime. There are use cases, if I show you one at least, where you can do something at definition time. Two different use cases, but most of the time it's runtime. So now I redefine my hello in a more sensible way. So I have a function, and then inside my function I have, this function you can call whatever you like. Here I call it wrapper or whatever you want. And then I use this syntax. Who is familiar with the syntax and knows what it means? Half the people. So I will explain the syntax in a second, because this is essential. And now I do this is my aspect. So the print hello, here in this case, it's the aspect. This is something I always want to add to functions. Print hello.
Is it one or double?
That's a double, thank you. Thank you, that's a typo. Yeah, typing and talking. And then I return my function, and I use the same syntax, one args and WK args. So KW args stands for keyword args, and args stands for positional args. And then I return my wrapper. And now I can do the same thing. I just can use this hello and apply the hello to my function A and B I define here. So, and see, now nothing happens at definition time, but when I add my numbers, I get my result, and in addition, I get my task that is the aspect, in this case, printing hello. You can do something more sensible, but this shows the concept of what you can do. And now if you look at the function add, it also has a different name. This is not nice. We will see later how to improve this, but now add is a different function because this one here, remember, this is just exactly like here. This is just this cell. This happens. So if you look at this, that this happens, then you always understand what's going on. Okay, now what's up is this args and keyword args. So you need to understand this concept to make sense of it. Otherwise, you can always use it as a recipe, but it's a good thing to understand what args and keyword args are. So you can define any kind of function, and you can use args. And I just say print args, and then you see when I call this function, I can call this function without any arguments, and I do get an empty tuple. If I call this function with one argument, I get a tuple with 1. If I call it with 2, I get a tuple with 2, and so on. So this star args is collecting all positional arguments. So this function takes an unspecified number of position arguments, 0 to n. This is a very versatile function already. And this is the first one. The second star with a double star is for keyword args. And now it's a bit different. So if I call this function again, then you see now I do get an empty dictionary. And if I call this with an keyword argument, I get an empty dictionary with 1 element, and if I have it with 2 keyword arguments, with 2, and so on. Yeah, something like this. Of course, very often you combine it.
Can you make it a little bit slower?
Yeah, okay.
Thanks.
Okay, so this is the one that catches all positional arguments, and this is the one that catches all keyword arguments. And the position arguments will be packaged into a tuple, because a tuple preserves the position, it's a sequence. And the keyword arguments go into a dictionary. Nowadays, dictionaries also preserve the sequence, because they have their order since Python 3.6, but beforehand it was not the case. Yeah. So in general, dictionaries use a hash table. They don't necessarily have an order. That they have an order now, it's something particular in Python, but still, very often the order is not considered. So now we can combine both. Yeah. So now I just put both together, and then you might guess if I do this, then I can put them together. KW args. And now if I call my function without anything, I do get 2 empty structures. And if I call it with positional and keyword arguments in any kind of combination, yeah, so per convention you don't put a space when you call it like this between the equal sign and the value, then you get these ones. So this function can be called with any kind of signature, so any kind of combination of positional and keyword arguments. And this is important because it's like a joke code. This function can replace any other function in terms of signature. So it can replace any other function. If it does something sensible, I don't know, but you can replace it. And this is pretty powerful. And there's not much new because you know how to work with tuples, you know how to work with dictionaries. This is important. It is often in Python case you always come back to the same data structures and you don't have to learn yet another specialized data structures for something structure. You can use an old data structure, a tuple or list or a dictionary, and it's very worthwhile to learn all the methods of these data structures. So another way, you can also use a tuple to call a function. Let's make a list. Yeah. So now I can say list, print list, and if I print this list, it prints the list like this. But I could write print list square brackets 0, comma, list square brackets 1, comma, list square brackets 2, and so on. So this would print it out. But lazy programmers or good programmers don't type too much. You could also say, do this unpacking for me. This star unpacks. Yeah, this star unpacks, and here it unpacks this list. And it doesn't matter if the list has 3 elements or 30 or 300, it will feed them as single arguments to your print function. That could be useful. And this always works. And these are the 2 concepts we use here to write our wrapper. You see here, that's a definition line. Here we use packing, so we pack all the arguments in containers, and here we do unpacking, we unpack all the arguments. Because here we call the function. Exactly the same syntax, different context, exactly opposite meaning. It's like a light switch. If the light is on, you turn it off. The other way, each TV works like this, and 2-year-olds can figure this out. That's not that difficult. That's behind here. Yeah. So same syntax, different meaning, and it's just a container concept. You can also say the postal concept. We send just the package, and the postal office doesn't care what I put inside the package as long as it's not the big or the heavy, and I pay my postage. They will transport it for me. Exactly the same happens here. Package or container. In a container, same thing. You just ship a container, and you can put anything inside. As long as it's not something illegal, you can put anything inside and can ship it. Yeah, that's totally fine, and the container doesn't care. And this is a concept we use here. Good. If you understand this, all the rest is details. Good. But let's look at the details. So, a few things about best practices. So what we did so far, if I write a function add, so I don't need to copy, I don't need to type this. I have my function here, and I forgot the most important thing in my function. What's the most important thing in a function? The dog string, exactly. Good. The dog string. I forgot a dog string, so you can use single or double, triple quoted. By convention use double, and for normal strings I use single. Other people might have different, but I think it doesn't really matter too much. Add 2 objects. So this is the most important thing. So now if I have this one, I do have a doc string which you can access via this doc attribute, or a lot of other tools, like in my notebook, the question mark will do exactly this, access the doc attribute, and shows me the doc string here nicely. So this is very important. And the other thing would be the name. So if you look at the name of the function, then you would get the name like this. Yeah. So each function has a string and name. You can change this name. This is you might call it metaprogramming already. So if you do metaprogramming, you have to know what you're doing. It's very powerful, but it can be pretty dangerous. So you could change the name of the function if you want it or not. It depends on you. So if I take the same. it takes the same decorator and the same function and decorate it with my hello. Yeah, I put my hello in front. And now, if I look at my function and I look at the docstring, then I see my docstring is gone. And if I look at the name, then it's called wrapper because, why it's called wrapper? Because this is the name of this function I used here, which is not good because now the whole thing about decorators is to reuse a decorator. So if I use this decorator 50 times in my code, I have 50 functions called wrapper. Yeah, that's not nice for debugging, so you don't want this one. So that's why best practices is to use a decorator. So from functools, yeah, functools is a functional features. So I thought it's a functional programming import reps. So we're not lunch yet, it's not nothing to eat, but it's a decorator. So you put the decorator here and you say reps, and you have to tell what it reps. So it's kind of redundant, but you have to say you rep this function. And this, if you look at reps, it does nothing much, just replacing a few attributes like the docstring, the name, and a few others. It just goes to the original function and copies from there to the wrapper. So the wrapper is still a new object with a different ID, but all the attributes, it looks good enough that you think it's the original function. So if you use an is test with the ID, you will get a different thing because it produces a new object. But all the attributes will be now much nicer. So if I do the same thing again, so I can do this again. So you have to run the notebook in sequence, otherwise you have to give new names for the functions. Now if I look at the function docstring, then you see it's still there. Still there. Yeah? And also the name should be much nicer. It's add. So you can look at the code. It's not very difficult. It calls other function. This one goes through all the attributes, and there's a list of attributes which might change a little bit if you use a different Python function. So if a new Python version gets a new attribute to functions, then they might add it to the list. So if you use this one, you don't have to do it by hand, because for the right Python version, they have the right list of attributes you need to add. Yeah. This can be a bit tricky if you do this inside a class with nested methods also. It might be strange because it looks for a module, and some functions that are generated dynamically don't have a module attribute, and then you get the error message, no module. Then you would need to write, if you look at there's this reps calls other function where you can specify the list, then you could modify the list if you really wanted to. It's possible. Good. That's best practice. Always use a decorator. And do this. Recursion, when you use recursion, then you have to be careful. Once you decorate a function, the function will call the decorated function, not the original function. And then you might have some, you execute the aspect in every recursion. But recursion is something you should try to avoid in Python if it's possible. It's not very performant. So when you can do iteration, always do iteration, and use recursion only when you have a problem that really lends itself to recursive processing, like nested nodes or something. That could be something. Otherwise, recursion is not the best thing to do in Python. Good. This is the basics of decorators. Let's look at a few use cases so to give you a feeling what you can do. So I have a few use cases. When you unpacked the source code, you should see some of these Python files. So there's a bunch of other stuff in here. Some Python files, and I just load them here, and I load this cached. Yeah, I load this caching thing, cached. I call it caching, cached. And this is a very, very simple cache. So don't use it in production. This is just a proof of concept how to make a cache, and I use a decorator. So I use pickle here to generate a key. So the pickle module in Python. That might work for you or might not work for you. And you see now we have the same thing. We have this this decorator. This is this def. So this is a scaffolding over C. If you have two defs, you have to have two returns. Very easy. Later on we see it has three defs nested, but we stick with two. So I put the cache in the outer function. This might not be the best architectural decision to do it because you cannot reach it easily from there. But for this purpose, it should be fine. So A dictionary typically is the first thing you go with a cache, and you could also easily make a persistent dictionary with shelf or something like this. And then we have our args, keyword args, and here you see a pattern. Very often you call this cached, and the nested one underscore cached, just because this name will disappear anyway. That's just a temporary name, so to speak, but you have to give the name, then you use the underscore. That's pretty common. And you see, this dumps is just pickle. This creates a tuple with all args and keyword args. So a tuple of the arguments and the tuple of the keyword args. And of course, now the objects have to be pickable. So if you hand something in that's not pickable, it's not going to work. Yeah. So, and then I just say, okay, if the key is not a cache yet, then I do call the function and produce a result and put it into the cache dictionary. Otherwise, you just return it. So caching is usually only useful if this function is expensive. So for our example, what we're using now, so if I execute this and I put my my decorator cached in front of our add function. Yeah, for this function, caching wouldn't be useful because the a plus b, if it's numbers, if it's not something very big, you never know. So plus can do anything. But if it's just numbers, this would be much faster than do this caching thing. And now I need to add something here to make this visible. Yeah, and I add adding. And now if I add my thing, now you see. It calls the function and shows adding. Now it returns a 9 and doesn't call adding. Now it shortcuts it. It just takes a result from the dictionary and doesn't call the function. That's the principle of caching. And with a decorator, you have a kind of elegant way to turn a normal function into a cached function. Yeah, turn a normal function into a cached function. So that's possible to do. And you could also, very often you apply this decorator with this syntax, but you could also use the other syntax when you, as we used up here, this our syntax thing. So sometimes you want to keep the old function around and make a new function, then just use a different name here, and then you can do it also. That can be useful. That's also a use case. Yeah. The original function, by the way, is available. So add has an attribute called wrapped, and this points to the original function that is not cached. So it's always there, you can use it. So these dumble things are typically internal names of Python. You have to know what they mean. Don't invent them yourself. Read up what they mean and use them accordingly. Defining them, you have to read the documentation, otherwise your object might behave maybe not the way you intended. Yeah? So otherwise, they are useful for reading. When you modify them, you have to really think maybe there's a better way of doing it. Sometimes it can be useful. So when you do debugging, you can do anything with your program. Yeah? And you can do all kinds of nasty things because you throw a code away and you're done with debugging. When you write something that's still a little bit longer than a few hours, then don't do it. That was a question? Yeah, the cache is stored in the func. This is the closure. That's a good question. So if you look at this cache thing, then you look at this at the add. They should have this closure, if I'm not mistaken. So see if we have it, and you have two closure cells, and you can look at the cells. And the first one is the cell content, and this is my cache. Yeah, this is a dictionary, and this thing is, there's a B, there's a bytes, there's a pickle thing. So it's now I use a closure and store it in the function. This is not, you can still access it, but maybe it's not the best way. Yeah, but just a normal dictionary, and the dictionary is modifiable. I could say this, give it a name cache, and I'll say clear, and then remove everything from the dictionary.
So each function that has been decorated will have its own cache.
Yeah, because you make a new closure. Yeah, so. That's one way of doing it. It's just an example. In the real world, you might want to have this cache as a global variable or use something else to put the cache somewhere else. Make an argument. So you can also, when we see, we can use a parameterized decorator, and you can even hand in an existing dictionary as a cache if you want. That would be possible. Yeah, that's just the principle that you can do something with this with this cache here. Good. So this would be one use case, and caching is a prominent cross-cutting concern because caching usually has nothing to do with your domain logic. You can use caching for all kinds of problems. And that's typically what this aspecting is all about. You have some tasks that you can need at many different places, and then you have a decorator and you implement it once, and they can use it all over the place. Good. This would be here. The next one is logging. I have another example. So I load my logging, logged, and you see now I do something differently. I have a constant, a global value, which I call the constant. So constants don't exist in Python, but per convention, if you uppercase the whole thing, you call it a constant. Yeah. So now it's the same thing. So we have two levels. So we use our reps. So we have our logged here, and now this one inspects the logging. If logging is set, it does logging. So in this case, my logging just is a print. It's not really logging, but it's just about the principle. And then the rest we know already. So the only thing different is here this logging. So and if it is false, so now I can do the same thing. So instead of course I'm too lazy, I use this, but we don't need the print here. But instead of cached, we say logged, yeah, and we log the thing. And I have to execute the cell first to get it to go. Yeah, logged. Okay, and now I have called my function, and you see no logging happens because this constant logging is false. Now I change the constant. So changing a constant during runtime is kind of dubious, but for testing you can do it. I change the constant, and now if I do this again, then I do get a logging. So I can turn on and off my logging globally by changing this value, and I don't have to sprinkle a lot of ifs around my code all over the place because I can only do it in the decorator once. That could be useful. And sometimes you want to switch something on and off. You can only say also I could change verbosity, how much is logged, what log level, and so on. All these things you know. This is just a principle to give you another example for cross-cutting concern. So you can probably come up with other cross-cutting concerns for things you might need at different places. Good. This is the basics. Any questions? I don't know if the Slido thing, do we have Slido in here? Yeah, so if you have any questions so far. Yeah?
If I would want to learn about the structure of the cell contents, for me it seems kind of, I have no orientation in the cell contents.
The cell contents, usually it's interesting though, but it's not essential to understand decorators because it's stored there under the name when you just access it, and how it's done technically, it's not that important. I would say it's just if you want to know how it works, then it's a closure, and inside the closure you have this content, and it's in this tuple, and these in the order they are used, they will be stored, and then Python will access them. Yeah, I think about this. The details are not important to write good decorators for this purpose. Mm-hmm.
And so is it specific to Jupyter, the cell contents, or would it?
No. There's nothing here specific to Jupyter. I just use Jupyter as a tool because it's easy to present step by step. Everything what I do here works in any kind of your IDEs, just plain Python. Here's nothing special about Jupyter, and only the execution is interesting here. Yeah, another question? No, good. So this is the basics. Now we know how to write a decorator. Another question?
So for the logs function, this has this underscore before, which is like usually this is kind of a private method, right?
Yeah, this is in general this is per convention a private, but here's just used because this name it disappears anyway because this reps makes this function name disappear anyway because this one is just a temporary function that doesn't serve any purpose. It doesn't want to have an own name because it's just a helper. And very often it's a convention use the same name as outside, and the distinguisher just use underscore. Theoretically, you can use any name. That doesn't really matter because this name doesn't appear anywhere because you want it to go away. Yeah. Yeah. So the underscore is nothing special. It's never special in Python. It's just a convention. If two underscores in the class, it's different name mangling, but with one, it's just a convention. Pretty strong convention. So. Yeah, good. Okay, basics. Yeah.
So you said that the is comparison will give false if you have a decorator. I think.
Yeah, should. The original function, the new function will have, so, because so if you have add is add dot, this is original function.
Yeah.
Yeah.
So is there any way that you can compare this and get it true?
No, because is object identity. You cannot mingle with the is. You could mingle with the equal sign. I haven't, because equal sign you could do this if this is classes. You could do this instead of function using instances that are comparable. Then you could implement the LT, the EQ, the equal, and then you can make it equal. So because if I use a double equal, I'm not even sure if it's implemented for functions. I never used it because then you could. Yeah, this gives you false. But if you really want it, then you can use if you really want it, you can make this true. But why? I'm not sure. Another question?
Instead of returning the original function, I also use this, and is there any use case where
Yield? No, yield is different. Suppose yield has a generator function, and even it's called a generator function, it's a totally different beast. It's not a function anymore. Yeah, so is a yield you won't get, and because yield is for this iterator protocol, and it's called generator function, but you could just give it maybe a totally different name, generator whatever, and not function. Because you use a function syntax, but as soon as you yield, this thing behaves totally differently than a function, it wouldn't work. Because it has no return or nothing, it's just not going to work. Yeah?
If I write a decorator that does logging, I probably want to apply that to like all of my functions.
Yeah.
What's the easiest way to make sure
Yeah. To all of the functions, there's meta methods. You could go into the namespace because you can use this method. So if you want to do it pragmatically, then you would use this syntax up here, which I showed you, in this syntax. If you use this syntax, then you can do it pragmatically. You only have to get all your functions somehow. Yeah, the namespace, globals, locals of a module is available. It's a dictionary. You can go through and decorate all of them. That would be a bit meta programming. Not very difficult. You just have to get all your modules, which you can import, and then you go through the global, and then you figure out who's a function, and maybe figure out by name which functions you want. There would be a lot of conventions. I'm not sure if it's recommended. It's technically possible. I'm not sure if this is a good concept because it's very indirect. You don't see that they are decorated. So maybe explicit is better than implicit. I don't know how many functions you have. If you have 10, maybe just write 10 decorators. If you have a few hundred functions, then maybe rethink your architecture to have them in a dictionary in the first place or something. Yeah, so it's possible if you want, because you just can use this one. You can always programmatically apply decorators to functions and replace them. There might be some corner cases I don't cover here, and you might get some surprises to do things you do. Yeah, that's what can happen. It's just a question why you want to do it, and maybe there's a better way to achieve what you want. So I wrote a decorator. You can also decorate methods of a class, and you can write a class decorator that decorates all the methods. That's pretty easy to do. That's not very difficult. If you want to, we can do an example. And that makes maybe more sense, because then you have all this. So if you want this, then instead of writing functions, just put all your functions in the class and then use a class decorator. And then say class decorator, give it a good name, and then you can see, all these methods are decorated automatically somehow. Then you say class decorator, take this decorator, then the class decorator decorates all the methods. I don't know if I could throw this out in a few minutes, but this wouldn't be that difficult, yeah?
Not coming up later, but so far we have decorated just the function. The decorator just takes the function as a parameter.
Yeah, it comes up later. That's next. Parameterized decorators, you mean? Yeah, that's the next one. So I would stop now the question, cover more, and we can do more questions later. This is the basics, and since there's basics, there's more advanced usages. And I do make a new notebook, if I can get my mouse under control here. And we say advanced. So now I'm skipping the exercises, and you're encouraged to do the exercises, write your own decorator, and this exercise is writing a decorator that uses time it, default timer, which is a timestamp. Just measure other functions. You do a timestamp before, run your function, do a timestamp later, and get the difference. This is pretty coarse. There are better methods, but for an example, it's good enough. And then you can put out of decorator function, you would automatically get the runtimes of these functions. You can't get as fancy as you want. Is there, you can just print it out, or you can store them. And if you call a function multiple times, what you do with the time, there's a lot of options there, but this would be the exercise here. So in terms of time constraints, I do go to the advanced section. So if we have our hello decorator, and I want to write a goodbye decorator that says goodbye. So if I have my nice hello decorator somewhere here that works, this is one without the wrapper. This is a better one down here with a wrapper. So I have hello here. If I have one that says goodbye, I copy the whole code and change the string to goodbye, right? Yeah. So if you copy a whole thing and change it very little, that should be a red light. This is obviously not a good way to do it. Don't repeat yourself. So if you have this whole thing, just replacing this with goodbye might not be a good solution. So I would make it a more general solution and just add another level. Yeah. You can solve any problem with another level of indirection. And that's what we're doing here. Now I call it say, and I call this text, and I put this in. So, and I just indent the whole thing. And important, you have to match the returns with the definitions. And I export something. Now I can change the names. So here I use underscore say, yeah. And here I change hello into text. So hopefully you survive all these changes, text. And here I change wrapper to double underscore. So that's, yeah. And typically there are not more than 2 underscores in Python, but we are going to, so that's where we're going to stop. And then I say here return double underscore say, and here return single underscore say. So you see, we just add another level outside, otherwise it's the same. And then how do we get our text from there to there? Again, that's a closure. Now we have a double closure if you want, because we have another nesting level. So, and now I can use my decorator say, and I can supply the string I want to have here as hello. Yeah, you could also say call greeting or whatever you want, or just print out, or doesn't really matter. Def add A and B, so I skip the doc string here, you know it has to be there, return A plus B. So and if I call my function, it does print. Yeah, so now much better. The functionality is exactly the same, only the data is different, the text, and now I want to hand in the data. So you have to do this. Now, if you want to write this one in one line, this is not that easy. So doing the same thing, so I define this function. Yeah. So now I have this say, and this say returns back a new function that calls the function, I have to say add equals, and this one calls add on it. And I hope this is correct. Yeah, I have to get rid of this add sign. So if I do this, now my add should do the same. That's what it's doing. Yeah, see, I get a bit tricky because this first consumes the parameter, or the argument in this case, hello, gives me back a new function. On this function I call giving the add. Yeah, so if you're a functional programmer, that looks very easy. If you're not so used to functional, it might look a bit scary here. Yeah, but that's what happens in the background, and we can do something like this. So this would be parameterization, and that's used a lot. See, if you use a tool like click, then you always put some kind of parameters in there. So, okay, this is a command line command, and then you say, okay, what types or whatever you put in there. If you use Cython, you specify the data types. Yeah, and Cython is something you can compile Python to C, and it's useful to specify C data types to make it faster. That's the whole purpose of the thing. Now, if we have this, we are not restricted to one decorator. You can always apply as many decorators as you like. Therefore, when you write a decorator, you should never assume you're the only decorator. Yeah, and you see now, if I call my function, then it says hello and goodbye. So you can put as many as you like, no restriction. You have to be careful, those static method and class method, I think they always have to be the innermost decorator. There are some of the built-in ones, they are a bit tricky, and if you put them in the wrong place, you get a strange error message. So you have to read up on the documentation, because these are they do something special. Yeah, so they violate the concept that it shouldn't matter what order you use and decorator, but when you write your own, you better write it in a way that it doesn't matter if it's called the first or the last. Good. So you might have seen some web developments where they have a lot of decorators, a big stack of decorators. Yeah, and then if we have more, yeah, then it's typically called a general because it's highly decorated. You know, so that's what they do. It's not my joke. I got it from the web guys. Yeah, there it is. So good. This is decoration, and this improves a lot. When you get away without a parameter, do it. If you don't, then you have to use a thing. So now we have this 3-level thing, dev. And if you use a tool like McCabe or so, and it analyzes your code for complexity, every level of indentation or nesting increases your complexity according to this tool. Yeah? So. But we can kind of reduce it a little bit, because now I would introduce the concept of a callable. So very often when you say Python and function in Python, then you don't mean function, you mean callable. So I can call sum to sum something up, or I can call int to turn a string into an int. So there are different types. If you look at the type of sum, this is a function. If you look at type of int, what's the type of int? It's a class. A type. If the type is type, it's a class. So it's a class. So here, actually, if I say I call this function int, that's wrong. In my beginner courses, I often say I call the function. It's not totally correct, but it's good enough, because int is a callable, not a function. So you can always check if something is a callable by checking callable. Callable, and a sum is also callable. Yeah, they are both callable, so you can always use these callable built in to see if something's callable. It means you can write normal parentheses. So I always say parentheses, square brackets, and curly braces. So you can use normal parentheses here to make it do something. In this case, it calls new and init and all kind of stuff in the background, but you don't care. You just use the parentheses, and you get something back. And if it's a type of a function or type of a class, doesn't matter. That's a basic principle of Python. Very often, the type of an object doesn't really matter. The protocol, the behavior matters, what the function can do. But actually, it's very often not so important. Yeah? There was a question about typing. We don't cover typing here, but typing goes to the direction just away from types more to protocols, more about the behavior. Is this iterable? Is this whatever it can do? Is it callable? And so on. Good. Now, we can also make a class callable. This could be interesting. So I make a class, and I call it call counter. And then I have an init. I have an init and myself, and I just set my counter to have a count, and I set it to 0. This would be the first thing I do. And then I do have a dunder call. So we define a special method, call. So now we have to know what it's doing. And I have self here, and I just increment it. So here you could hand in a function or do something more useful. The only thing now is what I'm doing, I'm increment my count. So to make it that's usually a good tip, to make the example as simple as possible, but still shows the thing. So for some reason, it doesn't remove the white space here, but yeah, just a thing. So I have my call counter now, make an instance, and now if I look at the count is 0, now I can use parentheses and call the thing, and this does nothing but now the count incremented, and you see the count is incremented. Now this instance is also callable. not only functions and classes are callable, this instance is also callable because it has this dunder call. So callable essentially checks for the dunder call. So if you look at this, now it's callable. And now we have a function with a state, so to speak. That kind of violates, so if you do functional programming, you might get some goosebumps now. Functional programming don't have states, but sometimes you want it. And here now you can make an object callable, and it can hold a state. Yeah, so callables could be useful. I think there's also the term functor flying around. I don't know those fancy terms is kind of a similar thing. Now we could rewrite our decorated function as a class, as a parameter-wise one. So we need from functools import reps. So we need our reps again. So I think maybe we have done up there, but it doesn't matter. Now we have a class, say. So here I capitalize. This might be, you might even want to write it lowercase. Typically classes are always uppercase, but when you use it as a decorator, you might consider writing a lowercase. I've seen lowercase classes and sometimes it makes sense, but I stay with the uppercase version here to show that it's a class. And now I use my init, myself, and I have my text, which is my parameter, and I have to store my text. And of course, I use self.text, so an instance variable, and the init has to have 2 underscores. And then we have our dunder call, and this dunder call is essentially this thing up here. So I can go and get these internals here. Yeah, I can take my internals and move them here, so make it a little bit more. So dunder call. Yeah, so double underscores usually called dunder self function. I have to give the function in here, and then I do something like this. So I can get rid of this one, and I can just use underscores. Whatever name I use, it doesn't really matter. I can just use a say here because it doesn't do anything. So that should be the same. Print, and of course now I have to say self.text. Yeah, so there might be some other copy-paste problem here, but that's essentially it. And now I should be able to use it in the same way. And I could use decorator, say, hello, yeah, at my add function, which I define now the 25th time, at A and B.
I think the assignment is missing. Yeah, I think the assignment is missing.
Yeah, thanks. Yeah, so I talked about it, but I didn't type it. So, thanks. Hello. Yeah, so the proof. This is the same thing as this triple nested function thing, but maybe easier to understand. So if you work with classes regularly, you might prefer this because you can also add other methods and do more in here. Yeah. And this class could do more. You can write the class that is a decorator and a context manager and an iterator at the same time if you wanted to. I don't know if you want, but it's possible. You could. Tyson's doing this. So Tyson decorators can also be used as context managers typically. Yeah, very often. Some of them. And then you can use everything you know about classes and just have this call and you have this callable, and it might be a bit more organized. You still have the same nesting level, but the class somehow doesn't feel like that deep. Yeah? Same thing, you have a callable, and if it gets more complex, you could use other methods, and this call could call other methods. So just you don't have so long a function. You can always use a function that calls other functions, but here you have everything together in the class, more organized. So different ways to achieve the same thing. If you write classes regularly, you might prefer this one because you might be used to it and have some other ideas to do here. Good.
Sorry.
Yeah.
So just to clarify, on line 24, the decorator is first creating an instance of the class.
Yeah.
And then decorating it using that.
Yeah. So.
Instance, right?
What's the answer to this question? Always go back to this approach. Yeah, so this makes it clearer. So if I say add equals, so the same thing what I said. So just that's what happens. So it makes an instance and then calls the instance with add. So first the instance, this is the init, and then this calls this call and give hence a function there. No, you make a new instance for each class. I'm using the class here. This is the class. I make.
As in, I can extract that instance into its own variable, and then decorate using that.
You could, but I'm not sure if this is the effect you want, because.
Maybe there's an idea.
Then it depends. Then you could, if you want to use this, for this one, everybody would get the same text. You can do this, so this would be possible. So for this one, for this special case, it would be possible if you want this effect. So I could do this, yeah.
Something I can think of would be some sort of consumer, maybe.
So this should work, and now I should be able to. I don't have to instantiate it all the time, and I can do something like this. So it depends on your use case, but it should be possible. If it makes sense, depends if you want them to share things potentially. Because now I have one instance, and now all the functions could share something over the self, if you wanted to. That should work. Yeah. So now that would work. Yeah. So now I could use it again, but you have to be careful if this. You're not supposed to, but you cannot prevent it from changing self.something. It's always possible. It's not good style. I wouldn't expect it, but who knows? And then these functions could communicate over the thing. Probably not a good idea. Yeah, another question?
Yeah, so to go back to, if we're not sure what the decorator does, to go back to the explicit line statement. And I was wondering, is that like
this one? So probably I didn't get this question, but this one is exactly, if you unroll this add thing and put it in a function, you see there are multiple function calls. I'm not sure if I understood the question.
No, it's about, like, if I put add, like the decorator itself, on a function, does Python internally resolve it to taking whatever I put?
Yeah, this syntax with add is, you can only use it in front of a def, otherwise you get a syntax error, pretty sure. So this def, this has to be a callable, and then it has to be directly in front of a def. Yeah. So, and this is also now something this one I call this function at import time. So in this case, when I execute a cell, would translate to like if I put it in a module importer, I do something at import time. So this is some kind of you can take over a little bit of the role of a compiler if you want these decorators. Yeah. So. Not exactly, but you can do tasks that a compiler, you can check things. Yeah, so compiler check types and so on. You could do similar things here with the decorator if it's possible. Not always, but most of them. Mm-hmm.
So the decorator also takes classes, data class, for example.
You mean as an argument here?
No, in the you can decorate classes.
Yeah, that's the next topic. We can decorate classes. Yeah.
Classes that you can only put the add sign right in front of the def.
Yeah, you can, in a def and the class, that would be a class decorator. For function decorators in front, yeah, you're correct. So this is the next topic, class decorators, yeah. So, good. I'll show you a few use cases, again, to give you an idea, and then we go to class decorators, which I always would like to cover. So, use cases. So the first use case would be argument checking. So it's something you can do. Now we have type hints and other tools that check for type hints, but maybe you want to do something more, and if just for the fun of it, you could do something like this, just as an example, arg check, and you can check arguments. And here I check just for the types, but you could check for anything. So you could check for a number that's between 0 and 100 or whatever you like. That's up to you. Yeah. So I use my func tools, and I use a 3-level approach, check, check, check. Yeah. And here I use a star, so I make the number of required arguments optional. This, we'll see in a second what it means. The rest is our scaffolding, our boilerplate. Yeah. Def, 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 return, return, return. And here I have to make it maybe a little bit smaller to fit it on the screen. Yeah. So I check for 2 things. So these archetypes are the arguments I desire to have, the types, and these are the arguments I get. We will see later on. And if they not have the same number, I do raise an exception and say, ich habe a type error with this message that they don't match in terms of length. And then I go through all of them. So with zip, I can zip together all the arguments and the types I desire to have. In lockstep, go to them, and if this argument is not an instance. So in Python, very rarely you want to check with type. Most of the time you want to check with is instance, because then you also would check for the parents of something. Yeah, there might be cases where you want to use type, but if you don't know, start with this instance. This is more general, it makes your problem more general, and it typically works better in Python. Yeah, so don't take everything as absolute. There are always exceptions. Sometimes you want type. But if you don't know, start with this instance. If it doesn't work, consider type. So, and if it's not the right type, I throw an exception, say, I don't like this. Yeah. So now I could use my decorator, and now I can say arc check. No, it's called check. Checked. Check. Yeah. And I have to define two types. I say I want to have floats now, and now I could reduce it to floats. So this, you could also put your own classes in there, no problem. And I have two arguments, return a plus b. So maybe I should write a macro to put this in. So I say add 3 and 4. Now it doesn't work. Yeah, it doesn't work. If I add a dot, then it's happy. And because now it's floats and it does what it does. So you might not want to use it in production, but instead of having float, you could also write a function that you call that is checking something. So you could write your own function that you put in, and then it's checking for some kind of thing. Yeah. So a string with a length of 5. I'm not sure if you can do this with typing. String a length of 5 that doesn't have an underscore on it. It wouldn't work with typing. Yeah. So, but you could write any kind of function instead of this is an example. Maybe I need to update this a bit, make a new thing, make a check for something else. But you might get an idea what you can do with it. So the thing is, you can use this pretty long check, and then when you apply it, it boils down to this short application. That's the whole thing. And you can use it again and again and again. Yeah, that's everything. Otherwise, you can always do it directly. Good. The next example is a bit different in terms of what it's doing, and it's called registering. So I can register something. So I have a registry, which is not the Windows registry, but it's just an example of something where I want to put something which I can find back later. There might be quite a few use cases for the thing. So you can put something that you can find back later. And I use a dictionary for this time. I don't put it into the function. I put it in the global namespace, so in the module. Now, my notebook is the same as a file. And I have this 3-level thing because I want to name these different kind of things with a name. We'll see what it means in a second. Function, my functional grabs. And here I say registry, and this is a dictionary, and I use set default. So set default is just a trick. So set default is going into the dictionary looking for the name. It finds the name, it retrieves the object, and then I append this object. If it doesn't, it puts in a new list and retrieves the new list, and I can append it. So I don't have to say, okay, if this is empty, put in a list with one element, and the next time I append to the list, I can do this in one line. This is nothing specific. This is just dictionary work. So if you want, I can take this apart. This is like 3 things at once here. Okay, but this is just appending to the list, and then I do my regular thing. So now I have 2 different ones. I have register at call, and I do have register at def. So we looked at call first, so let's do the register at call. So I use my register at call first, and I give it a name to have a category, and I define my function, a and b, and I return a plus b. Return, so it's a bit slow here, a plus b. Yeah, so, and before, actually, we look at the registry. Before I execute it, I look at the registry, and the registry is an empty dictionary. So I can inspect global variables here, so step by step, which is nice in the notebook. And if I look at the registry, now you see the registry is still empty, but now if I call my function, and I look at my registry again, now I know that my function had been called. And if I call my function again, doesn't matter what arguments I use, then if I look at my registry, my function has been just at the same function. So the list gets longer, so it's not particularly useful, but you see something happens, and you can, of course, implement whatever you like. So every time the function is called, I notice this in my registry. And maybe we need some kind of plugin system or something, so somebody supplies a function somewhere, and then it ends up in a registry or something like this. Good. So now, how to clean my registry? Very easy. Registry is a dictionary, so now say clear, and it clears the dictionary, registry, and everything is out again. Yeah. So registry, and now I do the same thing, but I say registry at def. So I'm lazy. At definition, yeah, and now I say complex or something. Complex. And now I look at my registry, and now something different. Now when I define the function, it will end up in my registry. That might maybe the more useful use case for this one. And if I call my function, nothing changes in the registry, because when I call it, nothing is different. Yeah. So whenever somebody is using your decorator and defines a function, it will end up in the dictionary. So you can kind of collect functions somebody else defines, for what purpose ever. Yeah. So, and you see now it's a bit different. So it's two level. And see here I return the function unchanged. No star double star game here. Nothing. So I don't replace original functions. I don't need reps here because I don't do anything. I return the function unchanged. But before I return it, I know that somebody defined it. That's why it's a registry. Yeah. So this is a use case where I mentioned this happens at import time. So if I import my module with a decorator, this will be executed, and I know some module I imported, somebody defined a function that's supposed to be somewhere when I'm supposed to be to do something with it. Yeah.
Is there a reason you used dict.setDefault instead of default dict?
Yeah, I thought about it, but you have to import from collections to default dict. You can do the same thing. This is easy enough here. That's why I don't have to introduce another data structure. But would we do the same thing? The default dict can do a bit more even than this one. Yeah, but you're right. Collections module has a default dict, which is doing this one. You just have to specify that's supposed to be a list in the first thing, and then it would do it. Yeah. But this would mean import, and then you have to initialize it, 2 more lines, and that's it. Okay, always argument. Good. Okay, this would be the example for registration, which is a bit different, and you can solve a kind of different problem what you wouldn't have. So these are function decorators starting from 2.6, I think, if I'm not mistaken. We have class decorators. Good messages, class decorators are a bit simpler than function decorators. And they are useful, and class decorators can take over quite a few things where in the past you used metaclasses. Anybody used a metaclass? Yeah, a few people did. So a lot of things you did with metaclasses you can do with class decorators. Not everything. There are a few things you still need metaclasses, but very few. And I never found a use case for these things too in any production thing. So it's not that common, obviously. And also there's an init subclass method which is new, which makes it easier because we will see class decorators you can inherit. You have to apply them on all the childs. The children don't get it. So let's look at class decorators, which we mentioned already. Class decorators. So what's a class decorator? So I just write a function, whatever it does. It takes a class, and the most important thing, it has to return this class. So now you're totally free to do whatever you want. So this is the boilerplate you want. And now you do whatever you like with a class. And you could, I modify it, but you can also just inspect it, which might be the more use case. Yeah. Now I say, okay, class dot new attribute or something. Yeah. New attribute something. Now I use this decorator, and now you're correct. You can use a decorator. No. decorator syntax here, and I can say mark, and I can mark my class A, yeah, and I don't put anything in there, I use pass, yeah, and if you look at the class now, you see it does have the attribute, new attribute. So this does exactly the same, so this is not very difficult. So this one is doing this. Yeah, so it gets a class A, and puts in the class. And this is exactly the same what the decorator is doing. But again, you don't have to, a class definition can be pretty long. You have to look at the very bottom of your class after 50 lines or 100 lines or 150 lines to see that this class is modified. You can make it very visible on top that this class is modified. And that's essentially what happens. Yeah? Much easier, no nested function definitions, just get the class and return the class and do something with the class. In this case, I add something that, yeah, maybe not a good idea, but you can also inspect the class and do something with the class. And for this, I have a use case. And I've forgotten the name of the file, but I can always check. Method name check. Load, method name check. So this is something, this is a little bit more involved class decorator. Actually, this comes from my tutorial about metaclasses. I used to use metaclasses first, but you can use it as a class decorator. So the thing is, I would like to inspect all the methods of the class, and if there are more than 30 characters, I don't like them. Yeah, you see. You can change the max length here, and I put some doc strings in here, and these are my things. Now I get my class, and now it's a bit more evolved. I define, there's a decorator here, and since I need to have 2 levels because I give it a parameter, same thing as before. Yeah, this is a parameterized one. So I give it a parameter, I have the 30. I get my class here, and I go to the dict of the class. So the dict of the class contains all the attributes. As a dictionary, with items, I get the key and the value, which I call name and object, which is more useful names here. And then if it's callable, so if it's a method, then I check if the length of the name is more than my specified 30 characters or whatever I specify, I don't like it, and I generate error message, which I put together here as with f string. Say, okay, this is here, that's what I wanted, but you cannot have names longer than this and this. Okay, so let's apply it first. We can look at the source code in a second. So as I go in here and say check name lengths, and I define my class class B, yeah, with a method which is fine. Method self. So when you talk and type, method self does nothing, pass, or def method with a very long name that is not nice. So I don't know, some other people do this. I don't do this. So okay. Okay, now do this and you see, I made a syntax, I forgot the colon. But when you put the colon and you do this, yeah, why doesn't it work? It should give me an error message. Yeah, the parameter. So I have to put the parentheses there to make it work. So there's also a way to make it without and with parentheses. And now I cannot do this. It doesn't like it and give me the error message. Say, okay, this name has 43 characters, only 30 are allowed. Yeah. So this could be useful. Yeah. So you could apply. You could check, and this one doesn't even import. So there's no way to start your program. If somebody, of course, if somebody just comments out the decorator, it works. But that's always yeah. That's kind of way. And now you could also think, okay, since I go over the callables, now I could say, please decorate all methods with this decorator. So as an argument, I give in a decorator, and then I have this one going over all these callable objects, which are the methods, and put the decorator on with this syntax, replace it in the dictionary. Maybe maybe not use a set attribute might be more. Yeah, set attribute is pretty much the same thing as replacing a dictionary, but there are a few things that don't go to dictionary, like properties, and so you have to be careful. This one you have to figure out what works for you, but this would be possible. So if you have a class with 20 methods, you want to decorate all of them, you write your own class decorator, and you say, okay, please decorate all these methods with this decorator. Maybe there's a different approach doing this, but it would work. It would work. Good. So I forgot another example here. Yeah, this is temperature check, but that's fine. Good. Class decorators are conceptually much more simple than function decorators, but nevertheless can be useful. Good. We still have 10 minutes, and we're pretty much through. Yeah, questions?
How would you efficiently test decorators, especially parameterized decorators, in a lovely fashion?
Yeah, in the end, it's just functions that return something. I don't think we need any special testing method for this. So it's a function that returns a new function. So I don't see anything particularly different than testing other functions. So maybe we need to make a use case for this where we say, okay, this is a decorator, and how do I test this decorator?
I mean, you have at some point nesting of 3 levels, right?
You have
the downmost level. Like how, for example, would you approach testing like the second level, dedicatedly ignoring the other 2 levels?
Yeah, that's not that easy, I think, because you have to syntactically put it inside. You cannot just write it outside and then inject it in there. Otherwise, you could like have this inner function as tested by itself and then just give it a parameter to put it in. I'm not sure if this is possible because it's the scoping thing. That would probably mean use eval or something. I don't want to do this. I'm not sure if it's possible. Have to check. But the whole thing is one thing. So probably what I would like to do, I just write the scaffolding, and then this one calls a function that does the work, and you test this function that does the work. Because this you only need a scaffolding. You only need this def, and then inside whatever you do, you call another function that does the real work, and you give it the parameters and get the result back. And you do the more complicated stuff in a separate function that does the work and not directly in the decorator. And then you could test this function separately. That might be the most sensible approach. Just divide and conquer. Yeah. Question?
This 3-level structure.
Yeah.
Can you just do like 2 decorators in front of the innermost thing and use that as a decorator?
I don't know what you mean. Use 2 decorators in the innermost thing. So that's a 3-level. This check is a 3-level one. Yeah.
And basically, you could have check as a function, check underscore as a function, and place these 2 functions as a decorator over check underscore check. Would that work?
You can decorate a decorator probably, yeah. So for this one, I cannot say yes. I have to test it out because it's like chess. You can only think so many moves. So I cannot do that. But it probably would work. Yeah.
Is it bad style to decorate the decorator?
This one is decorating in here and inside in the front. That's totally fine. Yeah, probably you could do this. So, but again, if you take this guts out here, yeah, and put it in your own function, that's what you want to do. In this one, you want to test, write in your own function, in a helper function that you can test separately, and you just call the function here and hand in this args. There's only the args and you just have to make sure this to reference these guys to put them in the closure. Otherwise, it wouldn't be there. Yeah. So, but that's maybe the easiest.
And there's an online question.
Yeah. Mm-hmm.
What is your opinion of using decorators for error handling?
I haven't used it for error handling. I use exceptions. I'm not sure how you can use error handling. So there might be use case. I'm not aware of a use case. I don't remember seeing one.
So usually you don't use it.
I haven't used it for error handling, so I have no experience with it. Potentially possible, but I don't know how exactly. So.
Performance-wise, is there a difference between using function-based and cloud-based decorators?
I don't think so, but I don't know. I haven't tested it. But it seems like the same amount of work. But I would need to test it, so I don't know. So, but it seems like the number of calls is the same, so it shouldn't be a big difference. Yeah.
If I wanted to use class decorators to count the instances of class that were actually created during runtime, would that be something that's doable with the decorator? Because I use decorators to time functions sometimes.
Yeah. Class decorators are for classes, not for instances.
So it's not possible. So I would have to decorate the init function and use that to.
Yeah, you can as you can use it. We have 5 minutes left, so you can always. So this one would always happen at definition time. But if you use this one you can do any time later on your code, and you don't have to do this. You can always make a new class with a new name. So you could always, instead of this, you call this, so you keep the old one and just give it the new name. Yeah? If it's a class, you would do something like this. Yeah? That's totally possible. And this one you can do anytime in your code. That would be possible.
So that if I want to decorate stuff, solving the task of counting the instances of my class is not something that's achievable by the kind of decorators that we just discussed. Like that's the takeaway.
Yeah. Do you need a decorator? Okay, so if you don't want to implement it in the class, but
if I want to, like, I have multiple classes and I just want to get an overview about what classes are actually implemented because I want to get an overview of the code. Like that's my use case, kind of.
Yeah, actually, I have something. I do have a meta class tutorial where I just replace. There's a function called generate. Do you want the classes or the instances? The instances. Then you can implement it in the class. I think we don't even need decorators for it. You just have a base class inherit, and then you use the init, and the init just counting how many times. It's very difficult about this thing because you might create new references, and this one gets deleted somewhere. You keep the reference right. You might want to use a weak reference stick for this, which is not that easy. So these kind of meta things you might generate some phantom effects you don't want with this. Yeah.
An online question.
Yeah.
Is there any significant overhead or performance traps when using decorators too extensively?
It's function calls. So function calls are pretty expensive in Python compared to other languages for sure, and you always add a bunch of function calls. So it could impact performance. It depends how often the decorator is called. So my register one is called only once. Usually it doesn't matter because it happens import time, which is expensive anyway, so you won't see a difference. But if you call the function that's decorated, that goes through all this jazz to find it millions of times in your code, you probably see a difference, especially if the rest of the function doesn't do much. If the function does a lot, then this extra overhead, its percentage-wise very small. But if the function is just doing 1 + 1 like here, then the decorator takes way more time than our A + B in our case. Yeah, it could have an effect. But again, this depends very much on the use case. Another question?
Do you have maybe more use cases for decorators, or like your favorite use cases, possibly in a data science, data engineering context?
So in general, everything that has nothing to do with your specific domain language you want to reuse in one way or the other. And the objectively could use inheritance, but then you always have a parent class and everything is inherited from this class. There would be one way of doing it, and with decorators you can get anything that's cross-cutting concern. So, and probably you can come up with something and say, okay, I program this, and here I program pretty much the same thing, and here I program pretty much, I think, 3 projects that are totally different, but I do a very similar thing. The logging, the timing, profiling, these are kind of these cross-cutting concerns where can be useful. And Cython and Mamba use it to specify data types because they compile to other languages. So if you want to go out, so if you access a database, you might, I don't know, give the column data types with a decorator or something. I'm not sure if this could be a use case. So not everything that's possible is a best solution. There might be easier solution. Yeah. So I don't want to sell you decorators. It's one tool in your tool chest you can use. There might be easier solutions, but for the fun you can try a decorator. Good. I think we're out of time. Another question?
I believe both click and even fast API, I noticed some of the libraries make the empty parentheses optional.
Yeah, you have to check. Here it's not optional. You have to recheck how I am called. This is meta programming. So you have to check I'm called with a parameter or not, and do I want to go from the 3 level to the 2 level version? It's possible, but I haven't put it in here. It's some meta programming. I couldn't do it right now. I have to look it up, but there are some Stack Overflow questions about it. I'm pretty sure.
It's a simple if statement. Like
Yeah. So you have to check if I'm called with a parameter or without, or if I'm used without the parentheses, I just kind of add empty parentheses to it, virtually, something like this. Good. So thank you very much. So if you would like to have more teaching, I have some flyers here. If you want more Python things, I do this for a living. So if you want me, I can come and teach you more. Otherwise, thank you very much, and I wish you a good lunch.